Okay, so starting with the next set of rapid fire for the 2024 10B, that's the way I call my sets of 5 problems. Been that way since the beginning. A rectangle has integer length sides and an area of 2024. What is the least possible perimeter of the rectangle? This goes back to older algebra textbooks used to have these problems, even Algebra 1. I call it the farmer's fence principle. And the farmer's fence principle would be if I had a certain amount of fencing that I could use. Let's say you had 40 feet of fencing. What's the biggest rectangular enclosure that you could make? And if you tried things like you said, all right, well, what if I did, let's see, a 9 and 11 here? And you would get, you got 9 over here, 11 over here. Your area of that is 99. Okay, but I wanted maximum area that I could get with 40 feet. And if you tried 8 and 12, which would also add up to 40 when you had the opposite sides, you would get 96. In fact, this spawns another idea that I use all the time. You'll notice that when you're dipping below the perfect square that's in the middle, I call it centering. The centered value on 8 and 12 is 10. And so if you go down from the center valued squared minus the gap squared, you'll get the next result. So 100 minus 1, what do I mean by the gap? The gap between 10 and 9 is 1, or 10 and 11. Either way, there's still a gap of 1. The centered value 10 squared minus the gap squared equals the result. So 12 squared, or 10 squared minus 4, because the gap is 2. So 2 squared 4, 96. And you can use that. It always works. But the main thing was the biggest area came from a perfect square. And the farther that you got away from a perfect square, the smaller the area that you could achieve. So if I'm trying to use the least possible perimeter, I would like to be as close to a perfect square as I can. And so if you paid attention at the end, in one of my last videos, somebody had told us what the prime factorization was, and I mentioned it. You should already know coming into the test every year what it is. By the way, next year it's 45 squared. So you can know that this is 2 to the third times 11 times 23. That is the prime factorization of 2024. So then now if we wanted to create two numbers that are approximately equal, you wouldn't want these two together. That'd be a problem. That'd be 253. And the other one would be 8. So you keep these separated like captains of a team, and you're picking the 2's to get split up. Kind of logical, you're going to put the 2 squared with the 11 and the 2 with the 23. That's going to give you 46 and 44 for a total of 90 for your length plus your width. So then you just double 90 to get 180. And you might say, well, is there any way we could get down to 160? And the answer would be no. Even if you had a perfect square, the best that would give you is 1600 for an area, not even close to 2024. Let's go ahead and get on to problem 7. Okay, problem 7 on the 10B. Again, this is a very standard modular arithmetic problem. For those of you who have not yet learned modular arithmetic, you can learn about it in the Art of Problem Solving's Intro to Number Theory. If you'd like to take a class where you can learn about those concepts, I teach those classes. One of the best ways that you can support this channel would be by taking classes with me. If you'd like to do so, reach out through my email. But if you can't afford classes and things like that, you can always self-study the book. I do have another video that has a modular arithmetic intro. You might want to search that up on my channel. You can probably find a video that gives you somewhat of a crash course in how that works. I forget the exact problem, but I did a long explanation of how modular arithmetic works in the beginning. So let's get to this one. By the way, there is 20% off if you take classes with me for your first 4 weeks of the class, and I will have a new number theory class starting probably in December. So reach out if you're interested. What is the remainder when 7 to the 2024 plus 7 to the 2025 plus 7 to the 2026 is divided by 19? Now I hope you noticed this was problem 7. Nice little Easter egg on their part, in my opinion. So you're dividing by 19, not the best number to divide by, but that must mean there's probably some shortcut somewhere that we can find, and we just have to look for it. You can look at 7 to the first, and we say that the remainder is 7 when divided by 19. In modular arithmetic, you say that this way. 7 is congruent to itself mod 19. This is what you're dividing by. That is either the remainder or in the same what we call residue class. All numbers with the same remainder fall into a same residue class, we call it. And so I'm not going to explain in great detail in this video just so we can get the problems out tonight. Now, when you square, you get 49. Now, you happen to know that 38 is a multiple of 19, and that 49 is 11 away from that. So you can say that 7 squared is congruent to 11 mod 19. Now, if I'm on my test, I'm not writing this every time. I might write it one time just so I can have a visual to look at what I'm doing. But after the first time, I'm just going to write 7 squared congruent to 11. Now, the neat thing about modular arithmetic is that I don't have to do it with 49. I don't have to use 343. You should have your first 12 cubes memorized and instantly able to recite them. 12 cubed is 1728, for instance. So 7 cubed, you don't need to use this number and divide 19 in. This is where you can lose time to somebody who's more experienced. They know that all you have to do is multiply the 11 by 7, and you're going to get 77. Now, thinking about 19, there's a number pretty close to 77 that's a multiple of 19. 19 times 4 is 76. You're just doubling 38. Should get there pretty quick, which means this number is only one more than a multiple of 19. And so we would say that this number has a remainder of 1 when divided by 19. Again, I'm writing that for your benefit. Now, you might not realize, let's go ahead and check right here though, by confirming that. So for those of you who are not familiar with the concept, you'll see it here. You put 1, you get 19, there's 15 and 3. Notice that that's 190, and 190 minus 38 would be 52. So 19 times 10 minus 19 times 2 would be 8. And so you're going to get 8 times 19 to get 152, and there is the remainder 1. Notice that this is much harder than multiplying just the 11, the residue of the previous one that we could get with that. And now you know the remainder is 1 for here. And this is, again, where your experience comes in. How comfortable are you with your modular arithmetic concepts? This would be like chapter, I want to say 14 and on in the Intro to Number Theory book, but highly recommend you do the earlier chapters before you start that one. There's lots of great nuggets that you can learn in there. So what are we going to do with this? When you get a 1 or a negative 1, yes, it's possible, those are great values to work with. See, we could just take this 7 to the 2024 and write it as 7 to the third times 7 to the third. All these, and they would all be 1s. And we call that process modding out the values. And it will work just like that. So what is the nearest multiple of 3? Because you're adding a bunch of 3's to 2024. It would be 2022. So if I did this up until you got to 1 that gave you 7 to the 2022, that number up to right there would have a remainder of 1 when divided by 19. Then all you'd have to do is go up to this 7 squared, and you're going to get a remainder of 11. Now, 7 to the 2025, that's a multiple of 3, which means it's just 1. And that's 1 more, so that means you're back at the first one, and you're just cycling in between these 3 for all time. So now you're going to have plus 7 there. Notice that 1 plus 7 is 8, and 11 is, in fact, we didn't even have to calculate. Once you saw that you were going to cycle all 3, if you were really experienced, better than I'm doing right now in this video, you would just go, well, whatever we have here, whatever they are, there's 1 of each. And therefore, I'm going to just be able to add all of these, and you get, of course, that the sum of them is 19. And since the sum of your remainders is 19, then the whole thing comes down to remainder 0. If that didn't make sense, I do apologize. I can't break down, several chapters of a book right here in this video. Hope it helps a little bit, and if not, leave a comment. I'm sure somebody will help, or go find the modular arithmetic intro problem that I have on my channel. It goes into more depth than this. Let's get to problem 8. Okay, problem 8 from the 2024 10B, yet another small notebook concept. Let n, capital N, be the product of all the positive integer divisors of 42. After this point here, we don't really care. Let's just find n. You can answer this question after you've processed the first part of it, and what exactly it's going to say is probably not important right now. We're thinking about it just yet. So I'm going to show you in mine. This is number 95, if I can get it on there. P sub n is the product of the divisors of n. It's equal to n to the power of the number of divisors of n over 2. I made a note that you can find this in Intro to Number Theory, section 5.4 as well. So that's what I'm talking about with the small notebook. For those of you that don't know, it's key ideas that you learn as you go. I had not really seen too many opportunities to use this one. I may or may not have covered it in the small notebook classes this year. Next year, they're probably going to end up taking a month. I did like 4 to 5 hours in all the classes, and we just didn't have time to get through everything. So maybe I'll turn it into a month-long class next year, each one being like 2 hours or something like that. I will look into that and get back to you. I'm always improving the way that I offer my classes as well. So I hope you were in one of the ones where we went over this. I don't think we went over this concept in all of them, or that you've done this book. For those of you that are already in my number theory class, you should have got this, because I know we covered this in depth for those of you that were in that class. Let n be the product of all the positive integer divisors of 42. So how do you find the number of divisors? It's just the prime factorization. So you do 2 times 3 times 7, you put exponents on it. All you're going to do is add 1 to each of the exponents. That's also a small notebook concept. The number of divisors of any integer process should be in your small notebook. So you add 1 to all of these, you get 2 times 2 times 2 is 8. Why does this work? Why are there 8 divisors of 42? And the answer is we're using fundamental counting principle. If you don't know what that is, it's as simple as, the easiest way to explain it, you've got 3 pairs of pants and you've got 4 shirts. How many outfits do you have? Can you make? 12. If you don't have any fashion sense, it doesn't matter what matches or what doesn't, you would have 12 outfits. The idea that you multiply the 2 number of ways, the choice of pants, choice of shirt together, is called the fundamental counting principle. Obviously, it doesn't have to involve pants and shirts. It can involve anything where the choices are independent and you multiply them as a result. So what are these choices? Why are there 2 choices? The choices are, you're going to pick either 2 to the 0 or 2 to the first, or 3 to the 0 or 3 to the first, or 7 to the 0, and you will choose one of these, and one of these, and that's why you add 1. You're adding 1 to include the choice of 0 power. These numbers, don't just do it from memory, understand what you're doing as well. That's very important. There are 8 factors of 42. Now, of course, all of you are like, well, I could just do 42 and 1 and 21 and 2. Sure, you can do that. Let me give you a larger number and have fun. I would learn this concept and make sure that you have it down. So now what? We said from that small notebook concept I just showed you that the product of all the positive integer divisors is going to be itself, the number itself, right? We had P sub n, go back and freeze the video if you want to see it again, is equal to n to the power of an exponent, T of n over 2. T of n is this, it's the number of divisors. And so you're going to get 42 to the power of 8 over 2, which is 42 to the 4th. Now, a fun thing you learn in number theory is that we don't care about this 4. I mean, we really don't. I mean, who cares about 4s? No, I'm just kidding. No, it's the units digit. The units digit is the only thing that affects the units digit. So all you have to know is what's the units digit of 2 to the 4th, and you say 6 because it's 16. You get answer choice D. Lots and lots of blitz problems like this on the contest, in the B test at least. Hope you learned from this one. Let's get to problem 9. Okay, now for problem 9. of this 2024 10B rapid fire set, which is again what I call my group of 5 problems. Real numbers, pause and take note of it being real. That might help later. It actually doesn't in this case, but we don't know what they are, but you always want to observe things like that, maybe underline it in case you need to use it for your reasoning as you go through. Real numbers A, B, and C have arithmetic mean 0. So immediately you would know A plus B plus C divided by 3 is 0, but of course that just means that A plus B plus C is 0. We don't need to divide by 3. That must be true. And right now I have a couple thoughts, right? You have these branch off ideas. You're like a frog on a lily pad, and maybe you go over to this next lily pad, maybe you go over there, maybe you go over there. And you have these little vectors of thought, you might call them. And you're thinking, I'm thinking one option right now is to move one variable over, like C is negative and A plus B is negative C. Which one do I want to move over? I don't know, but I see all of that in my mind in about 1 second. I just think about the potential. I don't actually do anything with it. It's an option that I don't know I want to take or not. Try to observe your options as you're working through problems, and don't forget to circle back to those if the thing that you try doesn't end up working out. But the thing that we're going to try is going to work out very well. This problem can be, again, just obliterated very quickly with a couple of ideas. Let's continue. The arithmetic mean of a squared, b squared, and c squared is 10. So a squared plus b squared plus c squared equals 30. What is the arithmetic mean of the pairwise products of the numbers? Okay, so how do you go through it quick? Well, this is something, again, if you took the small notebook class, we talk specifically about the way they teach the art of problem solving, the way they teach in their book in chapter 14 of Intro to Counting and Probability. I specifically pull that and show you the idea that they show for binomial expansion. Like when you're doing this, a lot of people know how to expand using Pascal's, and they know it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You know all that, okay? But do you see how they generate it when they're teaching that chapter? I try to draw attention to this in my classes when we go through Intro to Counting and Probability. I hope you understand it's very powerful as a technique, and we can use it here to go through what we're going to do in a second much faster. And the idea they show you, right, the reason why you get 1, 4, 6, 4, 1 is like this term here is going to be your a cubed b. Why is it a 4? Because from all 4 parentheses, you are choosing 3 of them to give you an A. Actually, we'll say 1 of them to give you a B. So if you say you chose this one to give you a B, and you choose an A from here, an A from here, and an A from here, there was 4 choices to make, and one of the parentheses, needed to be a choice of B. Every term that you create in the expansion of anything similar to this, you will select one thing from every parenthesis that you're multiplying. One thing. Okay, so that's how it works. Why is this 6? I choose 2 of the 4 parentheses to give me a B, and then 3 of the 4 to give me a B. 4 choose 3 being 4 as well. So if you understood that and you were in the small notebook class when I went through it, then I would like you to hopefully be able to get this. The thing is, why are they telling us this? What do we know? What are your facts? You're like a detective. So you're looking and you know 2 things right now. You know this, you have that vector of thought that we thought about that we didn't take. You should be saying, how do I connect these 2 things? Well, these are not squared and that is squared. So what should I do? Maybe I should square this because then I will get squared things, right? It seems logical. So I'm going to put A plus B plus C, and I'm not even going to write this. We're going to think about it like we did over there. The same thing that's here is right there. And think about what will happen. Actually, I will write it for your sake, okay? But I'll show you my paper in a second. If you take this A with that B, there's an AB. Notice that's one of the things we're looking for. But if I took this A with that B, which would also happen, I would get another copy of the product AB. And so from learning that chapter and understanding that you can expand the thought process to expand it to other parenthetical expressions, right? It could be a plus b plus c plus d to the fifth power. You can apply the same kind of thinking to quickly expand those. And you can expand this in a second. You know you're going to get an a times a. And think about the symmetry of what you're doing. Everything is equally represented in both parentheses. So if you get an a squared, you have to get a b squared and a c squared. Those are definitely going to be created because they all play the same role in both expressions. So now if I could take the left a and the right b and the right a and the left b to get 2ab, all of the terms will be able to do that. So you're going to get, I shouldn't have put equals, I should have put plus. You're going to get plus 2 times AB plus AC plus BC. And what's it going to equal? Whatever 0 squared equals, which is 0. And so you're going to do it just like that. You can quickly expand this, not having to do this thing that they taught you in school, distributive property. Okay? It's nothing wrong with distributive property, but you don't need to do that here if you understood that concept properly. And so you can just write that out in like a split second. Again, not a split second, but okay, maybe a few seconds, right? You just go right into that. Notice then as well that we know what this is. This is 30. And so all you're going to do is subtract 30, and you've got negative 30 over there equals 2 times, what's this? The arithmetic mean of that is what you're looking for. So I'm going to divide by 2, and you're going to get that what you're looking for, not yet divided by 3, is equal to negative 15. This is gone. We subtracted 30 from both sides, and then you divided by 2. So now you have this thing. And again, what do I want? Not just this. Luckily, they didn't put negative 15, so it wouldn't matter anyway. You'd know you did something wrong. But if you add these 3 things up, which is what that parenthesis is, and you divide by 3, now you'll have your answer, which is A. I'll show you what my paper looks like for this when I was solving. See if you can kind of see it there. Notice the other parenthesis on the right. There's nothing in it because I don't need to see that. I've got a squared, b squared, c squared. I just lined them up underneath it right here. And I've got 2ab, 2bc, 2ac. And I just put 30 plus. That one has to be negative 15. I didn't even move it over on mine. And you can just quickly get that it's A. Okay, so that's how these ideas that we learn in the small notebook class get played out. They give you speed advantages. And you don't have to take the class to get them, but go through the entire intro series and note everything that you can. Go through all the past contests and note everything that you can. Take notes from these videos right now and add it to your small notebook. Okay, that's it for this problem. Let's get to problem 10. And the final problem from this rapid fire set for the 10B, problem 10 of the year 2024. Quadrilateral ABCD is a parallelogram, and E is the midpoint of the side AD. Let, and right there at the let, you should go, wait a minute, what is going on here? I don't have a picture. So maybe I should draw one, and so just to kind of get an idea of what's happening. Obviously they don't give you a picture, then, I mean, I can make a bigger one for the camera's sake. Some of you complain sometimes about the picture not being large enough. So we'll go a little bit larger. See if I can draw accurately here. Okay, that's as close as you're going to get to accurate. It's hard to draw from the side and have your lines be perfect and everything. So we've got A, B, C, D, A, B, C, D. Is this what it looks like as a parallelogram? Answer, we don't know. So wait, if you don't know what it looks like, how are you drawing it? Because you need to do something. If you don't have any kind of idea, you can have a starting conceptual drawing and change it later if you need, but don't sit there paralyzed trying to design it in your mind. Just create something and then improve upon it, okay? So E is the midpoint of side AD. We go here to a midpoint, you put E. All right, now what? Let F be the intersection of lines EB. Let's go ahead and go draw EB and AC. We'll go over here. Sorry, I'm probably in your way, but I'm sure that you figured out where things are going. So have that drawn. What is the ratio of the area of quadrilateral, or F is right here. What is the ratio of the area of quadrilateral CDEF to the area of triangle CFB, which is this over here. Interesting. Okay, so there's probably a lot of things that you thought of. I did several things in the beginning. In fact, they don't tell us any lengths. If they don't tell you lengths, can you just plug some in? Yeah. If some of you plugged in numbers for lengths, it should be fine. In fact, I suspect strongly, although I didn't confirm this before filming, you could just make a rectangle. But we don't know it's a rectangle. It doesn't matter. It should be that if you don't violate any of the rules, a rectangle is a type of parallelogram. If you don't violate any of the rules, all the setups that people could make, all the conceivable ones, must collapse to a single answer. So if you made a rectangle and it worked out, leave a comment down below. I'm pretty sure it does, 99% sure, but I haven't fully confirmed and I don't want to say something that's false. But when I did make a rectangle temporarily, but then I abandoned that path because I realized what I would rather do instead, which we'll get to in this solution process. So I had a couple different attempts with this before I settled upon what I thought was going to work best. Anyhow, questions is this. You, again, are a detective. So, Sherlock, what do you observe? What are your clues? You have to ask, why did they tell me blank? What am I supposed to do with that? And that's where you attack the problem. If you don't know where to begin, go visit the facts of the case, like a detective would, and figure out what they're trying to have you use. So, E is the midpoint. Why did they tell us it's a midpoint? Don't know. Let's go ahead and mark this X and X. That would make AE a midpoint. That would also make BC 2X because opposite sides of a parallelogram have the same length, or they're congruent, okay? That should give you your clue. You're basically looking at the upper and lower triangles of a trapezoid. If I just connect E to C, you have your trapezoid, AECB. There might even be a trapezoidal solution that you can do. I started one and then decided I didn't want to work with it anymore. If you continue with the trapezoidal solution by connecting E to C, let me know in the comments below. I kind of want to do it in class on this video. Maybe I'll explore it in a second. Because one thing you would know if you connected E to C is these two triangles have equal area. That's a small notebook concept. It's covered in my class. The side triangles of every trapezoid have equal area. I'm not going to prove it to you right now. Take the class if you'd like to see why. So because these are equal area, this triangle EDC is actually 1/4 of the whole thing. And the triangle AEB is 1/4 of the whole thing. That I can demonstrate. It's just simply that the altitude from C to here would be the distance between two parallel lines. And that distance is constant. It never changes. So that's a small notebook concept as well. If the distance between the parallel lines never changes and these have the same base and they have the same height, they definitely have the same area, triangle AEB and EDC. Then furthermore, the one over here with twice the base and the same height as well will equal their area because it's got a base that's twice as big. Therefore, this whole piece is 1/4 and that's 1/4. So I'm kind of curious if this works right now. I haven't actually attempted it on my paper yet. Maybe this won't work. But if I take this triangle, which is 1/4 of the whole, and I add this triangle, I'm still going to need what that triangle is, but we're going to get that in a second using the fact that these two are similar. What makes them similar? Well, they have vertical angles and they have alternate interior angles. Alternate interior angles are equal by virtue of parallel lines. Once you have two angles that are equal, you have similar triangles by AA similarity. So since you have similar triangles, we also learned this in the small notebook class, your lengths are in a ratio of 1 to 2, therefore your areas are in a ratio of 1 to 4. So you could do that this way as well to get that, but all of your lengths are 1 to 2. So you could call this length C, and this would be 2C. And you could call this D, and that would be 2D. So now, looking only at this triangle AEB, knowing that it's 1/4 of the whole. I'm going to redraw it over here so you can see what's happening. A great strategy in general for all triangles is, or diagrams, is to redraw part of them so that your brain can tune everything else out and you can focus on what's going on. You've got D here and 2D here. That's a 1-to-2 ratio on the bases, which is same base, same height principle. I believe it's taught in section 4.3 or 4.4 of Intro to Geo from the Art of Problem Solving. Since we have the exact same height right here, then the ratio of the bases, this height right here is the height to both triangles. The ratio of the bases is the ratio of their areas. So since we said this triangle, A, E, D, B over here is 1/4 of the whole thing, then this one over here will be 1/3 of 1/4, which makes this triangle right here 1/12 of the whole. And this, of course, will be 2/3 of 1/4, which is 2/12 or 1/6. That would make this one also 1/6 of the whole. So you have 1/4 of the whole thing plus 1/6 of the whole thing. That is your quadrilateral. Again, I did not do this on my paper. This is not how I solved it. I'll go over that way in a moment. Instead, I just saw it right now and thought we'd do it live on this video. Next up over here, now you're going to look at probably triangle ABC. Triangle ABC, we're going to redraw that as well. Redraw that as well, ABC, and only this part coming in, that's C and 2C. They have the same third point, they have the same height, it's the exact same concept, 1-to-2 ratio in the areas. However, when you look at AC, it's the diagonal of a parallelogram. It created two congruent triangles. And since they're congruent, they're each half of the whole. So I take half of the whole multiplied by 1/3, and we get the same 1/6 we found the other way, but more importantly, we get 2/3 of 1/2. 2/3 of 1/2 is going to cancel the 2's, and you're going to get 1/3 of the whole area is this triangle right here. And that's going to give you this. And now how do you get rid of complex fractions? Don't you dare add these, that's so slow. Instead, multiply by the least common multiple of all of them, which is 24. 4, 6, and 3, no, 12. 12, just kidding. I didn't say that, you didn't hear it. 12. Multiply by 12 over 12, and you're gonna get 3 plus 2 is 5. 12 times 1/3 is 4. We have answer choice A, 5 to 4. Again, did not know that would work at the start of this video. I just got too curious and wanted to explore it as a trapezoidal approach, knowing that these two triangles are equal area. Let's go ahead and solve it the way I actually solved it on the test right now, where I did not draw this line. It's going to be very similar, but we're not going to do it in the same exact way. So instead, for this version, we're going to use the fact that we're still going to find this part right here, this triangle AFE. Earlier we said that that was 1/3 of 1/4 of the whole area, which is 1/12. And so if I look again at ACD, it's 1/2. So I took 1/2 minus 1/12. So the big triangle minus this triangle, which is 1/12 of the entire shape, whatever it is. And the other side, same exact way, we're going to do, I think I found this one as, what do we say, it was 1/6? 1/6. So then we said that it was 1/12 minus 1/6 is how I did that. Or wait, no, hold on, 1/2 rather, minus 1/6 right here. That's how I did it on my paper. If you did it that way or the other way, either way works. There's probably other ways too. There's probably lots of ways. So if you just multiply this by 12, you're going to get 6 minus 1, and this by 12, you're going to get 6 minus 2, and again, you get 5 to 4. Same exact answer, done in a different way. Let's go ahead and get on to the next problem.